Yeah, so the talk is called Are Programming Languages Languages? My name is Alvaro Videla. I work for Microsoft, and as you can see, things are changing at Microsoft. But for some reason, they gave me this Mac has a broken USB-C port, so maybe it's some kind of punishment to me. Anyway, I always add a slide or an intro to help me chillax because I start getting very anxious at the talks. So today is the International Day Against Homophobia, Transphobia, and Biphobia. And in Uruguay, particularly, last year we approved the law pro-trans rights. Some years ago, we approved the equal marriage law, also the abortion law, marijuana for everybody law. 100 years ago, women could already start voting in Uruguay. Even earlier, we separated church from the government. Just saying this because sometimes people say, hey, you are from South America, and everybody even says Mexico when they are in North America. And yeah, so that's just brief things about where I come from. But we are here talking about languages. The title was going to be Programming Languages Are Not Languages. That's kind of the spoiler already, so I decided to change it. And this talk was motivated because I was reading a paper by Matthias Feleisen, that probably you know him from the Racket programming language. And he wrote in a paper on the ACM that as programming language theorists, we ascribe or we support the Sapir-Whorf idea or hypothesis. And for me, that I've been studying linguistics, when I read that, I got triggered because we will see during the talk why I think that it's kind of not problematic, but we need to be careful on what we bring from different disciplines into programming. So that's a bit why this talk exists. But in the end, instead of being so combative, let's see what are the similarities and differences between natural languages and programming languages. So what do I mean by are languages? Like the question part of the title. Is do they have similar behavior for humans in the same way that natural languages influence our behavior or not? We will see during the talk. So, language in the phrase programming language is a metaphor. I know Thomas talked about metaphors. Brian before also talked about metaphors. And yeah, there is an idea from the late 70s which is called generative metaphor, which is that whenever you need to solve a problem or frame a problem, it's good to have a metaphor. Because they will give you an auxiliary language that will let you or allow you to talk about this particular problem you're having, and they will help you reason about the problem. So, as an example, let's take database replication. Also before, sorry, I don't remember your name, but you talk about Xerox. And the people at Xerox, they also were trying to develop database replication for the aviation industry, middle 80s or early 80s. And they come with the idea of rumor mongering. So basically, spreading rumors. And for South America, that's basically your daily telenovela, like how you spread gossip, basically. It's really easy to explain database replication and these ideas with rumor mongering, but it's quite hard to reason about. And they came to find a new generative metaphor, which is epidemics. And they saw that, yeah, the way you can replicate data could be like a virus spreading in a population, and then the next node has the virus, so it's contagious to the forward node. The virus will stay there for certain rounds of the algorithm. Then that node is not infested anymore with that data, so it's not passing it anymore, and so on. And magically, they got this mathematical theory of epidemics from the 50s for free. So, point is, metaphors, they enable understanding. They are really good for thinking about things. That I think is how the human brain has been optimized. Instead of storing millions of data, we can just relate one thing to another. But also, metaphors, they obscure understanding. And metaphors aren't like a one-to-one mapping. They are not that. So they always have some sort of problem. The stereotypical metaphor is from Shakespeare, at least in the English world, where they say Juliet is like the sun. But you understand that probably Romeo's life revolves around Juliet. He depends on her, and so on. But you never think that Juliet is giving Romeo skin cancer, right? Because the metaphor goes a certain way. So they also obscure understanding. So, with all that said about metaphors, at some point, there is this paper, which was a really good title, when technology became language. At some point in the history of programming, like Thomas was mentioning earlier, technology became language. It was cool to talk with this metaphor. So, what are the? Sorry, this is a subtitle of the paper: the origins of the linguistic conception of computer programming in the 50s and the 60s. So, all this became or started being used during the cybernetic or Kubernetes discourse back in the 50s, where computers were like human agents. So maybe there is a way to talk to them, and they will talk to us. Then, at the late 40s, they started with the idea that programming was a way to translate into a language that the machine can understand. Then I think Chomsky came along, and he really became like a celebrity in linguistics. And then we are computer scientists. We also like to be part of this nice wave of coolness, right? Probably it's the only way to get a grant back then. Never forget, probably maybe Thomas or another academic can confirm, you need to get money for grants. So today you are going to be serverless, I don't know what, serverless computation in lambda calculus, I don't know. Anyway, so yeah, they started also comparing programming with languages. And they tried to get away from this idea of just like some sort of notation that they were using, and trying to embrace more the programming metaphor, and started to bring in cross-pollination from biology, linguistics, and so on. So it's really a change in the industry or in academy as well, to start saying, yeah, these things we are using right now are languages. And for sure, I mean, I'm not here to argue that a programming language has a grammar and syntaxes and all these kind of things. I mean, that's not the point. I think the metaphor is very apt when we use it that way. Also, for the young people in the crowd, I mean, I wasn't even born back then, but there was code called automatic coding even in the 50s. Before it started being called programming. You can read Jan Sammet's book about the history of programming languages, where she tries to say what we mean by languages is something that has, for example, I think is an explosion of instructions, because you have a bunch of assembly that could be just one line of COBOL or whichever language they were using back then. But yeah, it was automatic coding. Or when we talk about software, we were discussing with people during the conf that in the 40s, who has an idea what was software in the late 40s, early 50s? Anybody? Yeah? But yes, so his answer is that in the early 40s was basically machine code and so on. But software and operating systems were the women programming the computers. So it took engineers to write operating systems, compilers, and so on to replace the work of a woman. So software has been changing during the history of programming also into what it means to do that. So you can imagine that language understood 60, 70 years ago is not the same thing that we take for granted today. So thanks to the programming language metaphor, they try to abstract or get away from all these machine architectures. Also, I think it was in your talk or the next one, or maybe Thomas, that they showed the IBM 360. They try to get into one type of architecture, because every time you try to do a new project, it was something different depending on the company you were working for. Even computers before the 50s, before the stored program, you plug the computer depending on the problem you wanted to solve. Elizabeth Holberton, she explained that when they invented breakpoints, actually she pulled a cable from the computer, everything freeze. They took a look at the lamps and say, okay, the bug is there, plug it again, keep running. That was debugging software back in the day. So they start needing a sort of universal language. And they wanted to insulate programming from all this rapidly changing technology and have some sort of island of semantic stability. So that was all really cool, really good intention, really nice. But as we know, scientists and we humans, we like to push metaphors to the limit. That, I think, is the reason why Haskellers like to claim that there are no good metaphors for monads. I think all the metaphors are pretty cool. But yeah, you cannot use for every single monad or every use case out there, call them a burrito or whatever it is that people call monads these days, right? Pipes, I think, was the latest battle on the monad frontware. Yeah, so let's see what happens if we push this idea of language. I'm in France, so you probably know who this Algerian guy is, Derrida, right? He wrote the book of grammatology. And in there, he quotes this guy, I think it's called Edmond Ortigues. I don't know what's the pronunciation. And he says, mathematical symbolism is a convention of writing. As scriptural symbolism, it is only by an abuse of vocabulary or by analogy that one speaks of a mathematical language. And then he says, algorithm is actually a characteristic. It is composed of written characters. It does not speak except through the intermediary of a language which furnishes not only the phonetic expression of the characters, but also the formulation of actions permitting the determination of the value of these characters. It's very complex, but long story short, in programming languages, there is no actual meaning of things except from whatever we write in English, French, Spanish, or Chinese. I don't know. So there is another book which I think expresses this idea a bit more clear by Umberto Eco. So you probably know him. He has written about everything, and everything that is to be written, probably he also wrote about that. And there is this book called The Search for the Perfect Language. It's about how in Europe, the great minds of Europe always try to find a perfect language that would represent reality. All of these attempts have failed. And of course, Eco talks about computer languages because it's Umberto Eco, right? The encyclopedia man. And he says that computer languages like BASIC or Pascal are in fact a priori languages. They are not full languages because their syntax, though rigorous, is simplified and limited, and they remain parasitic on the natural languages which attach meaning to their empty symbols. So programming languages are parasites of natural languages. And this is a very silly example, but when we look at the class person doing some things in some version of Java that I don't even know if it compiles, tell me something there that doesn't come or extract the meaning from English, in this case. And everything we write today, I was looking at slides from another talk in F#, it was just English. And how can we talk that languages, they have this kind of same properties as human languages when they don't even have a way to signify things? Maybe lambda calculus, I don't know, but in the rest of the programming languages, we actually use our own words. That I think is one of the main reasons for having programming languages, is to use a language that is easier to understand for humans, not for machines. Otherwise, just go to binary code or assembler. Like von Neumann used to say, real programmers programming binary code. And Elizabeth Holberton said real programmers programming actually the computer. So let's see who is the better programmer. Another problem, I think, with programming languages is if we try to look into semiotics. And I'm sorry for the French people, or actually Swiss people. I'm not going to talk about Saussure, but Charles Sanders Peirce. And this diagram, I stole it from a talk from Frieder Nacke that he gave last year in CodeMesh. I asked him for permission. And when Peirce introduced the idea of his semiotics ideas, he has that you have the sign, the linguistic sign is composed by a representamen, the object that is trying to say, let's say the word bottle, the actual bottle, and the interpretant, in this case, a human that is able to understand that when I say bottle, I mean probably something that looks like this. Not necessarily, it will be a beer bottle, whatever. But we are able to join this triangle. And machines, computer, they also have something like that when we write programs. But the difference is that humans, we have an intention when we interpret things, and the machine is determined. And I think this is something, as humans, we don't understand that is a problem when we program, and I will explain why soon. You can read it here if you want later. By the way, because you were the first to say something, there's your copy of the magazine. Now everybody will ask questions, I'm pretty sure. Anyway, there is an article about translation there that I talk about this. Anyway, what's the difference between humans and the machine? The machine, when it's parsing the code, it will point to just one place in memory or one instruction, let's say. We humans, a bottle, depending what's your idea of bottle, is what it will map to. And we can always negotiate meaning versus the thing that is encoded in the computer is just what is there, and there is no change despite how we could talk about it. We can have a meeting with a customer saying we need to implement an inventory for a supermarket, and we can agree on many things and discuss what inventory is and what is an item and whatever, stock, you name it. But the program that we have implemented is just referring to one thing. And let's say we have a six-pack of water, and suddenly there is no more single bottles at the supermarket. I go to the supermarket, I open or strip apart that, I just take one bottle, go to the cashier, they just send me a single bottle. And we that never work at a supermarket have no idea that users can do those kind of things, and our very abstracted data type, F#, I don't know what program just failed because we didn't consider that people could make single bottles of water out of 6 packs, just to name an example. And we could have agreed on that. We exchanged words, and as humans, we are, again, used to negotiate on meaning, and so maybe we thought that we share the same encyclopedia that the inventory manager has, when we actually don't, because we never work in a supermarket. And then what is the meaning of that? What is that interpretant doing? And in the other side of the computer, it just has one fixed thing. And until we don't go back to the code and change the code to represent the reality, we change the map, so it kind of gets closer to the territory. Again, it's just determined to interpret exactly one thing. And another philosopher, which I don't even remember the name, he talks that when we speak, you can probably notice already, not only my accent, probably my grammar is pretty broken for, for English. But as humans, we are always trying to push the limits of what's possible to communicate with language. And in a computer, you either follow the constraints of that grammar and that language that is there, or you're, it just won't compile. And even if, they say, if a hacker tries to abuse the system to get an overflow or I don't know what, it still is playing by the rules of the computer and the rules of that programming language, compiler, framework, whatever. So again, we have super flexibility in one side, and that's what we strive for as humans, I would say. I mean, I'm not saying that we are trying to break language, but yeah, we literally do every day. Every day there are new words. Some words will stay, some words will die. In Spanish, there are pushing for words that are more inclusive, like are gender neutral, which is kind of really hard in Spanish. Probably French people know as well the issue. And some of them, I'm pretty sure, will stay. Some of them will just die as a nice attempt. But we still understand. If I use a word in Spanish that kind of assume there is a gender-neutral thing, maybe you can get angry about it. But if you got angry about it, that you don't like the change, you understood what I was trying to say, that I was trying to be gender-neutral, even if I broke the language. In a program, try doing that, and good luck with the Haskell compiler error, right? And then the cutest hypothesis out there is Sapir-Whorf. And I don't know, yesterday I met somebody that likes to collect stories that are science fiction stories that are based on this hypothesis. And on the hard version of the hypothesis, like if you look at the movie Arrival, have you seen Arrival? Yeah. So, okay, there's another hand. There's your magazine. Oops, sorry. I'm sorry, it's just based on what is my vision. So, like, I'm a horse right now, so I only see the first, the first row. Anyway, so the movie Arrival is a movie based on the hard version or the strong version of the Sapir-Whorf, which is linguistics. Nobody believes in that version of the hypothesis. But as humans, it's really cute to think that my language and my culture has this very beautiful word that you can use, and I can express this idea, and you don't have it in your language, so we are better, because when we look at the sky, it's actually celeste in Spanish, and it's not light blue, and like, okay, bravo, who cares, right? Yeah, so there is Sapir-Whorf, and there is a strong Sapir-Whorf, and a weak Sapir-Whorf. And this is also what Feijleisen and I know other people have been saying that happens to when we use programming languages. And I started asking myself, like, what do actual languages, like natural languages, do to us as humans versus what programming languages do to humans? Do they really have the same cognitive influence that, let's say, being a Spanish speaker versus a Chinese speaker could have on you? I don't know. It will be pretty hard to test, I would say. But anyway, what do we know about Sapir-Whorf? So there is a strong version, which is language limits or thoughts. So basically, the language you know limits what you can think, what is possible to think. There is a really cool book which is called Women Talk More Than Men, Another Myth. So basically, it's spelling myth about linguistics. Spoiler alert, women don't talk more than men. And in this case, also try to dispel the Sapir-Whorf hypothesis. And one of their ideas is that if language will limit your thought, you couldn't even learn new words because you will be limited by the words that you already know. So it would be a very short-stopped how much you could progress learning languages, and not just forget about it, learning a different language, right? And then there is a weak version, which is if language influences the way we think, but for sure doesn't make an idea unthinkable. So is there at least a tiny version of influence or something like that? And next slide, I'm going to use a bad word, but I'm quoting here. And they say if the Inuit people have hundreds of words for snow. This is like, it's really cute to say that. Probably French people have 100 words for cheese, I don't know. Swiss people have 150 maybe, so I live in Switzerland, so I need to say that to be allowed back there. Anyway, this is something that has been kind of disproved or dispelled. The same way that people care about, can we see different colors depending on the language? I'm pretty sure everybody sees the sky celeste, light blue, or whatever it is you call it in French. I mean, I don't know. So yeah, because these cases are just concepts that are needed by society. There are societies that have, I think, 1, 2, and many. That's their number system. They don't have more than 1, 2, and many, or a lot of things. Colors is similar, depends on what you use. And the same with words for snow. And they say, like, what about skiers? People that ski also have a lot of words for snow. And people that weld have a lot of words for all the materials involved in welding. And we probably have a lot of words for whatever it is we do with computers, right? Every day there is a new methodology for programming, I don't know, whatever. Anyway. And besides that part, what is actually Sapir-Whorf? People just throw this idea out, and we don't even know what it actually means specifically from a linguistic point of view. And there is a really good book by Lakoff, which is called Women, Fire, and Dangerous Things. You may wonder why it has this weird title. In Aboriginal language in Australia, this is a category. So women, fire, and dangerous things belong in the same category. Don't ask me why. So it's a book mostly about categorization. It's really good if you're a software developer to understand how blinded, or maybe that's not the right word, but how conditioned we are by the categories that even are proper to our culture or to our social status. Yesterday, Romeo was talking about social capital or something like that. And yeah, if you are a white person living in Europe, there are so many things that you don't even think that could be possible in other sides of the world. I don't know. And the point is that in this book, there is a specific chapter about Sapir-Whorf, and Lakoff says that there are hundreds of concepts of linguistic relativism, which is the actual name of Sapir-Whorf. So, and it's not wrong. It's just different ways to look at the same problem. Like he said, there are different conceptualizations in everyday life. For example, we can look at love as a physical force. So we can be attracted to a person. We can first feel some sort of electricity or magnetism. Or we can look at love in terms of health. And yeah, you have a healthy relationship. The relationship is sick. It's on the mend. It's dying. Whatever. So it's just different ways to take a look at a problem. And in the same way, there are different conceptions of what he calls relativism. And here is when you need to look at how much variation is across the conceptual system. We will see some of this. How deep is the variation between different languages? What's the nature of the variation? Or do you behave differently if you have a different conceptual system, and so on? So depth of variation issue. We can look, there are languages that have different conception of space. There is a language in Australia as well that I think is the same language from the myth of the word kangaroo. You know, the kangaroo that the Australian didn't know what the Westerner was asking about, and they just say, like, I don't know, or something like that. That myth, I think, is attached to the same group of people that have a way of orientation based on the cardinal, like north, south, east, west, wherever it is they are here. So every time they tell something or they try to orient themselves, they will think not in front and back and right and left. They will use the north, south, and so on. So even they put like a TV show to them, and when they will narrate the story, they will say the main actor was walking south. He's not walking towards me. So you could tell even in what position the TV was based on how they will narrate the movie they were shown. So do you think programming languages go that deep into our brains to say that that Sapir word, let's say just this case, applies? I don't know. I don't think so. Maybe. Then there is a problem of time. I used to live in China, and it was very confusing because time in Chinese is vertical, and there is a reason for that. Because if you have a river, the water flows down right in the river, and Shang, which is on top or above, is the past, and Xia, which is where the down is where the water flows, is the future. So if you're in a train station, you will say that Shang, the previous station, is the one that comes from the past, and the Xia is the one that goes to the future. So they changed, for example, TV channels. The next channel is the down, I think, instead of up. I don't remember, but even the controllers are reversed. Yes. And compare thinking like that versus the way we look at time, like the time is behind us, future is forward. So those things are important. These other words, like chutzpah, I think is pronounced, agape, they are very localized. And for linguists, the third one, it doesn't really matter if you have the word celeste or whatever, because that's just a really local thing based on the reality you see every day, versus how you conceptualize time or space. And the more different time and space conceptualization are, the more different the system you have on understanding the world. And all these fundamental concepts, they tend to be grammaticized. And yeah, the more fundamental the variation, the greater degree of variation between languages. So again, probably besides, I don't know how many other reasons, time could be a reason why Chinese is just so different from the way we look at the world. And when I say we, I assume everybody's the same, so like I'm already doing like the worst thing possible. The nature of variation issue. We saw this earlier, many words for snow. Like, okay, cool story, bro, basically. Because snow is not fundamental to the conceptual system, and it's not part of the grammar, and we will see what we mean by grammar. Then again, skiers, they also have many words for snow. Simply show that they are experts on a certain domain. That's all that this thing shows. And also, there was this kind of view in the early 20th century that with words you will be carving the world and saying this is the limit and whatnot. Again, linguists don't care so much about that. They care more about what metaphors are born, another metaphor, out of these differences, like what gets grammaticized and what not. And then system versus capacity issue. This is really cool. And again, I will ask if this happened in programming languages. We can have a conceptual system and conceptualizing capacities. And an example will help understand this. So as humans, we assume, let's say, that everybody on the planet has the same capacities, but we can produce very different systems. So in English, the front of the body, we extend it to objects. So there is this language called Hausa, I will assume it's pronounced, where imagine I have a bush here. If I'm looking like that, the bush is facing me in English. But in the projection, the Hausa people do is to put the face this side. So the bush is not facing in the same direction I am. It's not facing me, basically. So point is that even something as basic as the human body, different languages have different projections on the world. Like there is another language, I think, from Mexico, where they have the head of the mountain is white. The computer is on the belly of the table. I'm standing, or basically on the back of the table, and I'm standing on the belly of whatever this is. And they have a whole projection of body parts to understanding the world. The birds are in the arms of the tree and stuff like that. And yeah, I can translate this to English, but the way of understanding the world is not the same. So again, in Sapir-Whorf, they ask, can you translate? Well, translate one-to-one, that will not be possible, but can you translate in a way that the other person understands? Yes, you can. I just did explaining this system of body parts. But the way this person will think about the world is totally not the same I will use when thinking about the world. So I ask again, can we say this happens in programming languages? I'm not entirely sure this happens, and I will explain why later. So again, we have same experience and same capacities, but in certain languages there are different outcomes. So, and then conceptual organizations. This is what I should say, like in this Chalcatongo Mixtec language from Mexico. They do this metaphor of projecting the body onto objects. So the stone is under the table. They would say stone be located belly table, for sure in their own words, right? He is on top of the mountain. Be located third singular masculine head heel. That's how they will phrase that. So we can understand the system because we also have a capacity of doing metaphorical projection, but we don't think like them. And also, there is a funny anecdote when the Spaniards priests, they went to Uruguay, they were asking the natives about how do you say, are you working today or something like that? And the natives, they gave them like a very long word. And they say, is that a word? Yes. And then, but how do you say he or work? And then they started separating in small words. But for the natives, what is even a word, right? Like because we one day invented the space bar, we think everybody has a space bar, let's say in their own language. I don't know, maybe don't. Early texts from Christianity or whatever were just one long thing without space. You can see that on Hebrew. Before the copies, they would just read aloud whatever was there. They had no idea what they were reading or no idea what they were putting down in those early documents when writing was just being invented or whatever. So I don't think I have time for this. This is quite interesting. There's this language called Hopi. I think this is the one that Sapir or Whorf, one of the two, were studying. And when these people mention any kind of motion, they need to use any of these prefixes, like waving, swaying, flapping, helical motion, turning, or quick spin. So Alvaro is, I don't know, doing a swaying with the hand. I don't know how you will present that, but they have to always think about what type of verb is, or motion is related to the verb. In English, we can say that Alvaro is waving hands, but it's not part of the verb, let's say. Or in Turkish, I don't know if there is anybody from Turkey here, but as I understand, you need to say if you are a witness of the action, versus just saying Alvaro gave a talk or I saw Alvaro giving a talk. But the verb saw in Turkish will include that you were a witness. So a Turkish person, every time they tell something, they actually automatically do that thinking behind the scenes. or subconsciously. We don't do that here, and I'm not sure this also pertains to a discussion of programming languages. So in English, the distinctions are part of the vocabulary, and in Hopi, they are just part of the grammar. They must do that every time they choose a verb. And my question is, do programming languages affect us at this level of cognition? I'm not sure that is so we can get there. And it's very important, but when they say like, what gets grammaticized, what becomes part of the grammar versus what is not grammaticized. And let me go a bit fast here. So whenever something is grammaticized, it's automatic, it's unconscious, it's effortless. It's just the way we do. In Spanish, you need to choose a number for the verb. You need to choose the mode. That is automatic. Whenever you say any type of action, you need to decide, are you affirming something? Is something that could happen? I mean, is it a possibility on this action? How many people are going to perform the action? And so on. This is always there. And for us, we just don't think about it. It's the way we speak. So are there any things that are grammaticized in a programming language that will make you think differently? The only thing that comes to mind is the way you program in languages like Erlang, where you don't have immutability. Whenever you do assignment, you're doing like pattern matching, and the variable won't change. In Haskell, you have that as well. That's the only place that I think it may make you face the problem in a different way. But at the same time, I think these are just tools or ideas that we can apply to any programming language. Let me just go through this. So I think in programming languages, we have all these tools, and for me, each paradigm or each programming language is more like a tool, or could be a nicer metaphor in this case than language, and they will give you or give us different way to solve or approach problems. And the beautiful PHP is there, because many times that people use appear-worth, if they use appear-worth to tell me that for some cases PHP is better than Haskell, I will believe that this is a real use of appear-worth. Most of the time, I think they're trying to say my language is better than yours. That's my take on many times I see that this is brought up. So if you bring it up in the same way that Hopi has advantages for some things and English for others, I'm pretty sure PHP must have advantages for some things and others. The same with OP versus functional, and my language is better than yours. Here, you don't see this happening live, but I need to change something here. This is the lambda. Don't change your slides before the talk. But there is a philosopher, Manuel de Landa. I think he's Mexican, but he's in Switzerland. I'm not really sure. But actually, he's quoting Derrida and Deleuze. No, Deleuze and Guattari, sorry. And this also makes me think a lot about how we are so jealous about or zealous about a language. And they say, there is no language in itself, nor are there any linguistic universals, only a throng of dialects, patois, slangs, and specialized languages. There is no mother tongue, only a power taken over by a dominant language within a political multiplicity. Language stabilizes around a parish, a bishopric, a capital. It forms a bulb. It evolves by subterranean stems and flows along river valleys or train track. It spreads like a patch of oil. It's like when we, former Roman Empire, argue if Catalan or Occitan is a language or not, and Spanish is, well, the one with the army is the language, the other is a dialect, right? And who says what is proper programming? Who can come and tell me if you don't do OOP with these design patterns, you are not doing proper Java, or if you don't use monad transformers, you are not doing Haskell or F#. I don't know. I think also programming languages have this thing that they just move around, and and evolve in different communities. And sometimes the PHP community, for whatever the reason, they adopted Scala, and then they started maybe doing some Scala that looks like PHP, and maybe they learn a bit of functional programming, and I started mixing all those things. So I prefer to see them as tools that move around, evolve, and help us solve problems. 2 more slides. You probably know that talk notations as tools of thought. Are they just tools for the way we think? And another one that this hits directly in the R programming languages is we come from literate societies, I would say, I would guess most of us, where since we are kids, there we are taught to write, read, and so on. But we can have language without any writing or reading, right? And I mean, thousands of years of humanity, that was what was there. There was no writing or reading. And programming languages so far, they only have this written thing that is interpreted by some computer, right? Outside of that, I'm not sure where they are growing or evolving or whatever. Anyway, long rant. Thank you very much. And there's your references. I don't think there's time for questions, but I'm around. Thanks.